All right, so today we're going to start learning about chemical reactions. So the big goal is being able to identify what type of chemical reaction is happening and then knowing how do we predict the product. So if you mix chemical A with chemical B, how do you know what you're making? So in our generic high school chemistry class, we classify chemical reactions under 5 different categories. Okay, so go ahead and write down these 5 categories. The first one is called combination or synthesis. And these 2 words are used interchangeably, so make sure you get them both down. The second type is called decomposition. Then we have single replacement, double replacement, and combustion. So most of the reactions we talk about, they'll fit into one of those 5 categories. However, I want to point out that every single reaction, like under the sun, doesn't necessarily fit neatly into those 5 categories. Okay. And so for the next probably week or 2, we're going to go through these type of reactions. So we'll learn about them in class. We will do a lab for each of the type of reactions, so we'll see them in real life, and then we'll do some practice problems where you practice predicting what the products are. Today, we'll learn about both the combination/synthesis and decomposition. So the first type of reaction we'll learn about, they're either called combination or synthesis reactions. You will see them as both, so you need to know it by either name. Okay. In a combination or synthesis reaction, you start with 2 or more reactants. Okay. And they're going to react and form one single substance or one product. Okay. So start with 2 or more reactants and you make one product. So if you want to add, you make one single product. You can add that in your notes. So then let's look at the word. So in combination, do you see the word combine? So you can remember these. They're like combining, right? You're going to combine substances to make one product. Or it's called synthesis. What does the word synthesis mean?
Synthesize.
To synthesize. If you're synthesizing, what are you doing? You're making something, okay? So think of it as like you're reacting multiple things and you're making just one product. So eventually we need to get to the point where you can look at a variety of reactions on paper and you need to be able to identify the type of reaction. Okay, so for this type of reaction, you're looking for one product. Okay. You'll have multiple reactants, one product. So that'll be like your cue that this is a combination. And then I have just a couple examples down here to show you what that's going to look like. So you could have sulfur plus oxygen, and it gives you sulfur trioxide. Or another example is calcium oxide plus carbon dioxide makes calcium carbonate. So in both of these examples, do you see how there's multiple reactants? And then how many products are there? Just one. Okay, one product every time. Okay, and then the next thing we need to be able to do with those combination reactions is we have to know how to predict the products. So if we mix 2 elements, how do we know what they're going to make? So in this class, we'll keep it simple where we'll only combine one single element with another single element and it'll produce a binary compound. How many, like binary, what number represents, like does binary represent? 2. So it's just 2 elements are going to form a compound. So for example, let's say we take iron, which is a single element, plus sulfur, it's a single element. Those are going to combine and just make one compound that's just iron sulfide. Okay, I want to do one more practice problem with you up here. So I want to do a practice combination reaction together. Let's say we take magnesium, and let's say we react it with oxygen. What's the chemical symbol for oxygen? O2. Okay, so oxygen is O2. And so they're just going to combine and make magnesium oxide. Okay. But when you make those formulas, you don't just squish the elements together. We have to go back to what we know about ionic compounds. Okay, so we're going to do charges. We're going to do the crisscross rule. So if we look at magnesium, what charge does magnesium get? Okay, so magnesium's a +2. And then if you look at the oxygen, what kind of charge does oxygen get? Okay, -2. Once you have those charges up there, what do? Crisscross. So we end up with Mg2O2. And then finally, what do we do with the 2's? They cancel. So what's the formula for magnesium oxide? Okay, so it's just MgO. So I wanted to show you this step. I want you to know, like, we don't just take the single elements and just put them together. Okay, I think I always give you ionic formulas, so you'll always do the charges, and you got to balance the charges. And then finally, the last step now is going to be to balance the equation. Is this reaction balanced? Okay, what do I need to add right here to balance it? Okay, so I'm going to put a 2 there. Now what do I have to add right here to balance it? 2. Okay, now is it balanced? Good. So from this point forward, if we're writing chemical equations, they need to be balanced chemical equations. Okay. And then I want to take a minute. I just want to do one more review. Okay. So let's talk about, where does this 2 come from in O2? We talked about this just a little bit last semester, but this is really the first time where it becomes relevant. Do y'all remember that word Brinkelhoff? Everyone say Brinkelhoff. Okay, Brinkelhoff is a little acronym we use to remember which elements are always diatomic, or it's like O2 when it's by itself. Also, if you have your naming chart out, if you look at the back of your naming chart, it's on the bottom left. Do you see there's a little section called diatomic? So now that we're starting to write those formulas, you need to be aware of these. Okay, I just remember Brinkelhoff, so I know if it's one of these elements. Br stands for bromine, I is for iodine, N is for nitrogen, Cl is for chlorine, H is for hydrogen, O for oxygen, F for fluorine. Okay. What this means is if they're alone, meaning they're not bonded, they exist in a pair. So it's like O2 instead of just O. Okay. Now, if it bonds, does that rule apply? Okay. It's only when they're alone. So you can either remember Brinkelhoff, or it's on your naming chart that you always get to use. However, if it's not on your mind, are you going to know to go check this chart? So you're not going to remember to check it. So I remember Brinkelhoff. The second type of reaction we'll learn about today is decomposition. Decomposition has the word decompose in it. What does decompose mean? To break down. So decomposition reactions are exactly the opposite of synthesis. So this time you start with a single reactant and it gets broken down into 2 or more products. And then these reactions typically don't happen on their own. So usually they need some sort of a catalyst like heat, light, or electricity. So an example of a decomposition reaction is water breaks down into hydrogen and oxygen. And water, does this happen all by itself? If you spill water on the floor, is that what happens to it? No, right? So in order for this to happen, you need electricity. Okay, so these typically you have to do something to make them decompose. And remember, we need to get to the point where if you look at multiple reactions on paper, how do you identify them? Okay. So what you're going to look for decomposition reactions is one reactant. Okay. So if you see one single reactant, then you should be thinking decomposition. Okay, that's going to be your clue that you're looking for. And on that same note, sometimes people really struggle with just having like one reactant and they want to reverse this equation. You cannot reverse it, okay? The left of the arrow is always the reactant, so you have to keep it with just one reactant. Okay, the last thing we need to be able to do is predict the products. So if we have a decomposition reaction, how do we know what kind of products will be produced? So again, for our class, we'll keep it really simple. So we'll only have a binary compound. What does binary mean again? 2. So we'll only have compounds made with 2 elements, and then they'll just break down into their single elements. So for example, If we have mercury oxide, it's just going to break up into mercury and oxygen. And if we have magnesium chloride, it'll just break up into magnesium and chlorine.